Alright, so this one we have 3.30. And I just actually want to point out, if you're looking at this problem that looked familiar, that's because it's the exact same as 3.7. So if you're getting stumped on this, you should use 3.7 to be able to guide you through, because that was a different way of doing it. That's the nodal analysis. This is the mesh. And actually, I think for this problem, I like the mesh a little more. But let's see what we got here. You can determine yourself. So first thing we do with this problem is write our meshes in. So I'm going to make my meshes right here. I'm going to make this one I1, nice and easy. I'm going to do this one, I2. I'm going to do one more, I3. Alright, so that's our first step of our mesh problems. Next, we're going to look at the mesh that we're first going to touch, I1. We're going to write it down, I1. And now we're going to add up the resistors that touch I1. So 5 plus 10. So 5 plus 10. And now we're going to see, does any other mesh touch I1? And the answer is yes, I2 touches it. So we're going to do a minus I2. And what does it touch it by? It's the 10 ohm again, 10 ohm. Cool. Now we're going to do equals a power supply, because we have a power supply here. It's going in the direction of current. So that's going to be 21. That's our first equation. Done. Boom. Our second equation, we're going to write our first one that we're looking at down. We're going to look at I2. So we're going to do I2. And now we're going to look at going around I2 all the resistors. So that's 10 plus 5 plus 10. 10, 5, 10. Cool. Does anything touch I2? Yeah, I1 and I3. So let's do minus I1 first. And what does that do? That's a 10 because it touches at that point. I1's going the opposite direction of I2 at that point. And do we have another one? Yes, we have I3. So minus I3, what does that touch at? That touches at 10 as well. And do we have any power supplies? No, so that equals 0. That's our second equation. Third equation, I3. What does I3 have? We have two resistors, a 10 and a 5. 10 plus 5 for I3. And now, what else do we have? Does it touch anything? Yes, it touches I2, so minus I2. And then what does it touch I2 with? A 10 ohm resistor? 10. And does it touch anything else? No, no. And so we can have that equal to, and then let's look, we have a power supply here. So power supply is going in the same direction as the current. See, it's negative, positive. It's just going in the same direction. So that's going to equal 10.5 because it's in the same direction. So that is essentially all we need for the problem. 3 equations, 3 unknowns. I1, I2, I3. So 3 unknowns. So I1, I2, I3, number. I1, I2, I3, number. So this one, we've got 15. We've got minus 10, we've got 0, and we've got 21. Cool. Let's go for the next one. 10, 25 for I2. That is I2, remember that. We don't want to switch that down here. No, no, no. I2. Minus 10 for I1. Minus 10 for I3 equals 0. Last one. I don't see any I1. I see a minus 10 I2. You see a 15 I3 and a 10.5 for that. And remember, A to the minus 1, B equals answer. So this is going to equal 2.6, 1.8, and 1.9. And that's I1, I2, I3. That's our answers right there. And so the last part of this is saying find Ix. So what is the current going through there? So this is wonderful. I love the way this works out. So we're going to have Ix equals. So what is the current coming down? Well, what's the difference between these two currents? That's it. We have I2 minus I3. I2 minus I3. Because remember, it's going down. So it's following the same direction as the I2. And that's why we use the positive I2. Okay? Current is going down. It's drawn going down in the problem. This we've drawn going in the same direction. That's why this one's positive. This is going in the backwards direction against it. That's why this one's negative. So just giving that out. Equals 1.8 minus 1.9, because we plugged in 1.8, 1.9, 1.8 minus 1.9 equals minus 0.10 equals Ix. There's your current. Minus 0.10 amps. Put little amps in there. There you go. See, this one is way easier to solve and way faster. Let me pull up the other one real fast just so we can do a comparison here. So let's just look. So for this one, this was the nodal analysis that we used. This was actually a solid amount of steps to go through. Then we had our matrix and we came out. This one was 3 equations right off the bat. We had a more complex matrix. This was a 2x2 matrix. This is a 3x3 matrix. But it's going to come out with the same answer here as there. So whether you're using 330 or 37, look at what the problem's asking for to make sure you're using the right mesh analysis or nodal analysis. Actually, this one didn't even describe it, so you could have used a mesh analysis here and done the same problem twice. But anyway, I just want you to look at kind of the elegance of 2 different solutions for the same problem. So that's that.